Good day to everyone. The topic of our lecture for today is UML diagram types. No single diagram is a model. Diagrams are just a means of visualizing the model. Only a set of diagrams makes up a model of the system and most fully describes it, but not one diagram taken out of context. 12 types of diagrams divided into 3 groups. 4 types of diagrams represent the static structure of the application. 5 represent the behavioral aspects of the system. 3 represent the physical aspects of the functioning of the system, implementation diagrams. Here you can see UML 2.3 diagram structure. All diagrams divided to 2 groups, structure diagram and behavior diagram. Structure diagram divided to the profile diagram, class diagram, composite structure diagram, component diagram, deployment diagram, object diagram, package diagram. And the behavior diagram divided to activity diagram, use case diagram, and interaction diagram, and state machine diagrams. And interaction diagrams can be sequence diagram, communication diagram, interaction overview diagram, timing diagram. The number of diagram types for a particular model of a particular application is not strictly fixed. For simple applications, there is no need to build diagrams without exception. The list of diagrams depends on the specifics of the developed project and is determined by the developer. We will briefly consider these types of diagrams: use case diagram, class diagram, diagram of objects, sequence diagram, interaction diagram, state diagram, activity chart, and deployment chart. And first type, use case diagram. Any, including software systems, are designed taking into account the fact that in the course of their work, they will be used by people and or interact with other systems. Entities with which the system interacts in the process of its work are called actors, not from the word theater and actors at the theater, but from the word action. Every actor expects the system to behave in a well-defined, predictable way. An actor is a set of logically related roles that are executed when interacting with use cases or entities, a system, subsystem, or class. An actor can be a person or another system, subsystem, or class, which represent something outside of essence. Graphically, the actor is depicted either as a little man, similar to those that we painted in childhood, depicting members of our family, or as a class symbol with a corresponding stereotype. So we can see that actor can be depicted as the serialized man and as class with a name, attributes, and methods. Use case is a description of a separate aspect of the behavior of the system from the point of view of the user. Use case is a description of the set of sequential events, including options performed by the system that lead to the result observed by the actor. A precedent represents the behavior of the entity, describing the interaction between the actors and the system. The precedent doesn't show how a certain result is achieved, but only what is exactly fulfilled. Use case depicted as the ellipse with a name inside. Precedents are indicated in a very simple way, in the form of an ellipse inside of which its name is indicated. Use cases and actors are connected using lines. Often at one end of the line, an arrow is shown and it's directed towards the one who is requesting the service from, in other words, whose services are being used. This simple explanation illustrates IBM's precedent of use cases as services. Precedents may include other precedents, expand them, inherit, and etc. Here you can see example of use case diagram. We can see two actors, student and librarian, and five services. Student communicate with the services, search the catalog or the books, working with a reading room. And librarian communicate with the services, issuing orders and consultation. Sometimes on the use case diagrams, the boundaries of the system are indicated by a rectangle, at the top of which the name of the system may be indicated. Precedents, that is, actions performed by the system in response to the actions of the actor, are placed inside the rectangle. Use case diagrams refer to that group of diagrams that represent the dynamic or behavioral aspects of a system. This is an excellent tool for reaching mutual understanding between developers, experts, and users of the product. Such diagrams are very easy to understand and can be pursued and importantly discussed by people who are not specialists in the field of software development. Purpose of creating use case diagrams. First of all, definition of the boundary and context of the modeled subject area in the early stages of design. Second, formation of general requirements for the behavior of the system being designed. Development of a conceptual model of the system for its subsequent detailing. Preparation of documentation for interaction with customers and users of the system. Next type of diagrams is class diagram. Class, that is the category of things that have common attributes and operations. Classes are the building blocks of any object-oriented system. They are a description of a collection of objects with common attributes, operations, relationships, and semantics. Classes are used in the domain analysis process to compile the domain vocabulary of the system being developed. A class diagram is a collection of static declarative model elements. Class diagrams can be used both in direct design, that is, in the process of developing a new system, and in reverse engineering, in the description of existing and used systems. The information from the class diagram directly maps to the application source code. Most existing UML modeling tools can generate code for a specific programming language, usually Java or C++. Class diagram, that is the end result of the design and the starting point of the development process. Here you can see example of class diagram. At the top we can see appliances and inherited from it kitchen equipment, iron, washing machine. And from the kitchen equipment we can see inherited bake and harvester. And from the bake we can see inherited electric stove, gas stove, and microwave. Another example of class diagram, we can see class human that interact with the class teacher, which in turn pointed to the chapter. And human interact with the class student, which is registered on faculty and registered on chapter. Class faculty offers a course, and chapter taught in audience, which is located in building, and chapter is during the period which connected with day and repetition. Another example of class diagram, first class with the name student, attributes name, address, telephone, Gmail, record number, and average performance. And methods can sign up, get a list of courses and taking. And the student recorded by class passing the course with the attributes estimates list, and the method get current GPA, get the final mark, and it's connected listen the class course with the attribute name, number, price, and method add student and remove student. And class professor with the attributes name, address, telephone, payment, teaches the course. And here we can see command connected to the connection from class professor to a class course. Some courses don't require the instructor and are designed for self-study. Next type of diagram, object diagram. Object that is an instance of a class. Object that is concrete materialization of abstraction. An entity with well-defined boundaries that encapsulates state and behavior. An instance of a class, or rather a classifier, an actor class of interface. An object is uniquely identified by attribute values that define its state at a given time. Object examples. The object of the microwave class from the example given earlier can be the simplest Saturn device of small capacity and with mechanical control, and a sophisticated unit with a grill, touch control, and three-dimensional energy distribution system from Samsung or LG. We are all objects of the human class and are distinguished from each other by such signs, attribute values as name, hair color, eye color, height, weight, age, and etc., depending on what task we are considering and what human properties are important for us in it. Object notation in UML. An object like a class is denoted by a rectangle, but its name is underlined. By the word name, here we mean the name of the object and the name of its class separated by a colon. To indicate the values of the attributes of an object, a special section can be provided in its designation. The object can be anonymous, that is necessary if at the moment it doesn't matter which object of this class takes part in the interaction. Here you can see example of designation of object. At the left side, we can see object with the name my machine from the class washing machine, and attribute manufacturer equals Samsung. At the middle, we can see class with the name C from the object with the name C from the class company. And the right side, we can see object without the name and from the class element. Object diagram, they show a set of object instances of classes depicted in the class diagram and the relationships between them at some point in time. An object diagram is a kind of snapshot of the state of the system at a certain point in time, showing a set of objects, their states, and relationships between them at a given moment. Object diagrams represent a static view of a system from a design and process point of view, providing the basis for scenarios described by interaction diagrams. Object diagram is used to explain in detail interaction diagrams, such as sequence diagrams. Here you can see example of object diagram. The top we can see that object of the class VP marketing connected with the object from the class VP sales. And in turn, it connected with the object from the class sales manager. And the sales manager connected with the object of class advertising specialist. And then it connected with the object of class printed edition. And also sales manager connected to the object of trading agent, of class trading agent, and trading agent connected with the object of class buyer. Another example of object diagram. At the top we can see object with the name C from the class company, and it connected with the classes with the object with the names D1 and D2 from the class department, and the class D1 connected with the object with the name D3 from the same class department, and the object D3 connected with the is the manager of the object with the name P from the class employer, and with the attribute name, ID amp, and disk. And the employee connected with the object from the class contact information and attribute address equal Pushkin Street 83A. Next example, object diagram of the robot learning environment for Turbo Pascal. At the top, we can see object with the name R from the class robot and the command moving. And it's connected with the object with the name W from the class Volt. And this object W connected with the objects, some number of objects from the class element, and also with the object A1 and A2 from the class zone, and object A2 is connected with the objects W1, W2, W3 from the class wall, and object D8 from the class door. Next type of diagram is sequence diagram. Sequence diagram displays the interaction of objects in dynamics. In UML, the interaction of objects is understood as the exchange of information between them. In this case, the information takes the form of messages. In addition to the fact that the message carries some information, it also affects the recipient in some way. Information interaction between objects is reduced to sending and receiving messages. Sequence diagram refers to UML interaction diagrams describing the behavioral aspects of a system, but considers the interaction of objects over time. Sequence diagram displays the temporal features of the transmission and reception of messages by objects. Sequence diagrams can and should be used to clarify use case diagrams, a more detailed description of the logic of use cases. This is a great tool for documenting a project in terms of use cases. Sequence diagrams typically contain the objects that interact within the scenario, the messages they exchange, and the return results associated with the messages. Sequence diagram notation. Objects are denoted by rectangles with underlined names to distinguish them from classes. Messages, method calls, lines with arrows, return results, dotted lines with arrows, rectangles on vertical lines below. Each of the objects show the lifetime focus of the objects. Here you can see a sequence diagram example, and we can see three objects. First object with the name listener from the class student. Second object without the name from the class seminar. And the third object without the name from the class course. And dotted line from the top to the bottom from each object, that is the lifeline of the object. Rectangles at the lifeline, that is time when object is doing something before send or receive message. So we can see such scenario that a listener enroll a student to a seminar. Seminar, after some time of thinking, sends message student prepared, listener to the course. Course send message to the listener with the message get seminar history. Listener send in request as answer history of seminars. And course after analyzing the history of seminars, send message to preparedness status to the seminar, and seminar sends message to the listener record status. Another example of sequence diagram, operation of conventional house, elevator. Passenger pressed the elevator button update the elevator controller, and controller sends message to elevator button to backlight, and then send message to elevator to move, and after some time elevator send message floor reached to the elevator controller. Floor elevator controller send message stop to the elevator, and send message open to the door, and in some time it sends a message close to the door. And after the elevator reached the floor, elevator controller sends a message put out to the elevator button. Next example, mobile phone operation. And for each digit, digital button pressed, and that is a message to digital key adapter, and from it message digit code to the delay device, delay device display number to delay display, and also send message make a sound to the speaker. And action with the call button pressed, call button adapter, and call button adapter call delay device, and delay device connect number to cellular radio transmitter, and it's in turn sends a message to the transmitter display to show status. Next type of diagram, collaboration diagram. The interaction diagram shows the flow of messages between the object of the system and the main associations between them, and in fact is an alternative to the sequence diagram. An object diagram shows statics, a snapshot of the system, the connections between objects at a given point in time, while an interaction diagram, like a sequence diagram, shows the interaction of objects over time, that is, in dynamics. Unlike a sequence diagram, time is not shown as a separate dimension in an interaction diagram. Therefore, the sequence of message transmission can only be specified using their numbering. So we can see the interaction diagram example that client, first of all, client sends message with the number 1, generate request name to the librarian. Librarian sends a message with the number 2, find name to the employer. Employer sends answer with the number 3 and return information with the name to the librarian. And librarian sends message with the number 4, give name to the employer. Another example of interaction diagram. User send message with the number 1, manage course to course administrator. Course administrator send message with the number 2, create course to course. And number with the number message with the number 3, create section to the section. And the message with the number 4, assign to course to the teacher. Next type, state chart diagram. Objects are characterized by their behavior and the state they are in. State diagrams are used to explain how complex objects work. A state diagram shows how an object transitions from one state to another. State diagram shows automation. State that is a situation in the life cycle of an object during which it satisfies some condition, performs a certain activity, or waits for some event. The state of an object is determined by the values of some of its attributes and the presence or absence of links with other objects. The state diagram differs from other diagrams in that it describes the process of changing the states of only one instance of a certain class, one object. Moreover, a reactive object, that is an object whose behavior is characterized by its reaction to external events. They can be used to construct executable systems through forward and reverse engineering. Symbols on state diagrams. The rounded rectangles represent the states an object goes through during its life cycle. Arrows show transitions between states that are caused by the execution of methods of the object described by the diagram. There are also two types of pseudostates. Initial, in which the object is located immediately after its creation, indicated by a solid circle, and a final, in which the object cannot leave it if it has passed into it, indicated by a circle surrounded by a circle. Here you can see an example of a simple state diagram. First state at the left side for the disk clean DVD array. And with the action write data, it's come to the state achieve volume. And with the action disk clean up, the state achieve volume, uh, go to the state clean DVD array. An example of a simple state diagram. And that is course completion. Some actions in parallel. Lab 1, lab 2, if completed, then go to the end. Next action from the beginning course project. If protected, then go to the local end. And then from the beginning, exam. If passed, go to the end. If not passed, go to the state failed. And the course completion. If everything local action go to the end, then uh, everything go to the state passed. If not, go to the state failed. Next example, timer state chart. From the beginning, we go with the signal on to the state time control check, and with the signal mode, we go to the state changing the hours, and from it, when everything is set, go to the state changing the minutes, and then when everything is set, go to the state time control. And if the button is pushed off reset, we go from the state time control to the end of action. Activity diagram. When modeling the behavior of the system being designed, it's often not enough to depict the process of changing its states, but it's also necessary to reveal the details of the algorithmic implementation of the operations performed by the system. As we have already said, block diagrams or block diagrams of algorithms have traditionally been used for this purpose. In the UML, there are activity diagrams for this, which are a special case of state diagrams. Activity diagrams are useful for visualizing the algorithms that class operations work on. Here you can see example of activity diagram about you, and from the beginning, after you waking up, you decide I am late or I am on time. When I am late, I drink tea and go to the output. When I am on time, then physical exercise, and in parallel to activity, shower and singing, and after this, breakfast and go to the output. Another example of activity diagram from the beginning, the action receiving order, then in parallel to activity. First activity, check availability in stock, postpone, and if not exist, then repeat in order again. And left activity, if payment refused, then reject order. If payment confirmed, then go to the next put in queue. Next example from the beginning, receiving an order and then two line of activity in parallel. First line sending a way bill and receiving payment, and from the left side filling in order and delivery. And if express delivery, then overnight delivery. If otherwise, regular delivery, and go to the end, local end, and then close order after both activity. Next type of diagram, that is deployment diagram. When we write a program, we write it to run on a computer that has some hardware configuration and is running some operating system. Enterprise applications often require some IT infrastructure to run, store information in databases located somewhere on the company's servers, call web services, use shared resources, and etc. In such cases, it would be nice to have a graphical representation of the infrastructure to which the application will be deployed. That's what the deployment diagrams are for, which are sometimes called placement diagrams. Benefits of deployment diagrams. A graphical representation of the IT infrastructure can help remove rationally distribute system components among network nodes, which, as you know, depends, among other things, on system performance. Such a diagram can help solve many auxiliary tasks related, for example, to security. The deployment diagram shows the topology of the system and the distribution of system components among its nodes, as well as connections, information transfer routes between hardware nodes. Here you can see deployment diagram example. So we can see here for computer. First computer with the database, customer database. Second computer with the database, sales database. And third computer, application server, sales and service. And fourth computer, that is customer service screen. Another example deployment diagram with a large number of nodes. At the middle, we can see workstation with a Unix X window, a point Netscape DM. And it's connected with the printers in the laboratory, with the print server and print servers connected with the printers in the lobby. Also workstation connected with the file server, and file server connected with the PPC KPI. You do Unix point telnet slogan, and this server connected with the modem to the PC modem and with the Netscape Explorer telnet FIP, and with through the telnet to ESP and PC modem too. Object-oriented programming and sequence diagramming. First of all, you must answer these equations for yourself. What types of diagrams best reflect the architecture of the system and the possible technical risks associated with the project? Which of the diagrams is most convenient to turn into a tool for monitoring the process and progress of system development? It can be suggested the following sequence of diagramming: use case diagram, class diagram, object diagram, sequence diagram, cooperation diagram, state diagram, activity diagram, and deployment diagram. And conclusions for the theoretical material. Diagrams of different types allow you to look at the system from different points of view. UML contains three types of diagrams to model the static structure, behavioral aspects, and application implementation details. It's not enough to read about UML, you have to use it. And now a short technical break. Let I check who is present. Albu,
Here.
Bodnar, Бурлаев, Гайтукаев,
Here.
Герасимовский, Горбатова,
Here.
Грамматикати, Зазуля, Караульный,
I'm here.
Карватска,
Here.
Ларби, Лыцар, Мараренко, Сиротенко, Сивак,
Here.
Степаненко Денис,
Here.
Степаненко Сергей,
Here.
Швец,
Yeah.
Щевель, Дымов, Чайка, Кушнир-Писаренко.
Чайка present.
Окей, Чайка. What about Кушнир-Писаренко? Окей, Давидович,
Present.
Глинка, which diagrams correspond to the static view of the system? And the first in line is Davidovich.
The diagrams that correspond to the static view of the system are the class diagram and the object diagram. The class diagram is a collection of static, diacritic model elements that describes classes, their attributes, operations, and relationships.
Окей, Чайка. Ну, Швец. Ну, Степаненко Сергей. Ну, Степаненко Денис.
Вибачте, можна відповісти? З мікрофоном
Who
проблема
is it?
була. Швець.
Окей, Швец.
Diagrams that correspond to the static view is class diagram, object, component diagram, deployment, and package diagram.
Окей, what about Степаненко Сергей? Степаненко Денис. Окей. Class diagram, object diagram, deployment diagram. Next question, which diagrams represent the behavioral aspects of the system? And first in line is Sivak. No. Mararenko.
Можна відповісти?
Is that Sivak?
Yes.
Okay, please.
Behavioral aspects of a system are represented by behavioral UML diagrams, such as use case diagrams, activity diagrams, and state machine diagrams, and sequence diagrams.
Okay,
This
okay, Mararenko. Okay. Use case diagram, sequence diagram, collaboration diagram, state chart diagram, and activity diagram. Purpose of creating use case diagrams. First in line is Karvatska. No, okay, Горбатова.
The purpose of creating use case diagrams is to show how users and other systems interact with the system.
Okay, Гайтукаев.
Yes, the purpose of creating use case diagrams is definition of the boundary and context of the model subject's area in the early stages of design. Also, formation of general requirements, development of a conceptual model, and preparation of documentation.
Really, so definition of the boundary and context of the model subject area in the early stages of design, formation of general requirements for the behavior of the system being designed, development of a conceptual model of the system for its subsequent detailing, and preparation of documentation for interaction with customers and users of the system. Next question, what is actor? And first in line is Albu. Do you want to answer this question?
Yes, an actor is a set of logically related roles that are executed when interacting with use cases or entities, a system, subsystem, or a class.
Okay, Davidovich.
Yeah, I want to repeat after Albul. So an actor is an entity, is a set of logically related roles that are executed when interacting with use cases or entities, a system, subsystem, or class.
Okay, Chaika. Okay, actor. This is a set of logically related roles performed when interacting with precedents or entities, system, subsystem, or class. An actor can be a person or another system or subsystem or class. What is a class? And first in line is Швец.
Yes, a class in programming and UML is a template or blueprint for creating objects. In UML,
Степаненко Сергей.
oh.
Maybe enough. Степаненко Сергей.
Class a category of things that have a common attributes and operations.
Okay, Степаненко Денис. No, Sivak.
A class is a blueprint or a template used to create objects and defining their common attributes and behaviors methods.
Class, that is a category of things that have common attributes and operations. They are a description of a collection of objects with common attributes, operations, relationships, and semantics. What does a sequence diagram show? And first in line is Mararenko. No, Karvatska. No, Горбатова.
A sequence diagram shows how objects interact over time by sending and receiving messages.
Okay, Gaitukaya.
Yeah, I can agree with previous statement that a sequence diagram just shows how objects interact with each other in a particular order over time.
Sequence diagram displays the interaction of object in dynamics. In UML, the interaction of object is understood as the exchange of information between them. In this case, the information takes the form of messages. Sequence diagrams typically contain the object that interact within the scenario, the messages they exchange, and the return results associated with the messages. What are state charts used for? And first in line is Albul.
Yes, state charts. State charts, its object are characterized by their behavior and the state they're in. And state diagrams are used to explain how complex objects work. And state diagrams show how an object transitions from one state to another.
Davidovich.
Yeah, I agree with Bulviera. So statement diagram are used for the explain how complex objects work by showing and how an object transitions from one state to another. State chart diagram shows an automation. It models the reactive behavior of an object.
State diagrams are used to explain how complex objects work. A state diagram shows how an object transitions from one state to another. State diagram shows automation. Next question. What are the characteristics of object? And first in line is Чайка. No, Швец.
The main characteristic of objects is identity, state, and behavior.
Окей, Степаненко Сергей. Ну, Степаненко Денис. Ну, Сивак.
Every object has three main characteristics: state, represented by attributes; behavior, represented by methods; and identity.
Objects are characterized by state and behavior. What is an object state? And first in line is Mararenko. No, Larbi. Okay. What about Larbi? No, Karvatska. No, Горбатова.
An object state is a situation where it does something, waits, or meets a condition based on its attributes and links.
Okay, state that is a situation in the life cycle of an object during which it satisfies some condition, perform a certain activity, or waits for some events. The state of an object is determined by the values of some of its attributes and the presence or absence of links with other objects. What does the deployment diagram show? And first in line is Gaytukayev.
Yeah, deployment diagram shows like the physical structure of a system, and it shows hardware nodes, software components, and how software is deployed on hardware.
Okay, Albul.
When we write a program, we write it to run on a computer that has some hardware configurations and is running some operating system. Enterprise applications often require some IT infrastructure to run, store information in databases located where on the company servers, call web services, use shared resources, and etc. In such cases, it would be nice to have a graphical representation of the infrastructure to which the application will be deployed. And that's what deployment diagrams are for, which sometimes called placement diagrams.
The deployment diagram showed the infrastructure of computing facilities. That is, it shows which computing nodes we have, by what channels they are connected, and which components work on which computing nodes. That's all questions for today. Thank you very much for your attention and for your answers to the questions. Your points for today: Albol 6, Gaytukayev 6, Горбатова 6, Mararenko 4, Sivak 6, Stepanenko Sergey 2, Shvets 6, Davidovich 6. If you have no questions to me, I wish you to have a nice day and see you next week. And now, goodbye. Have a nice day.
Thank you. Bye.
Thank you. Have a nice day.